Hello students, welcome to Power Tutorials. So let's continue our question bank series. So if you are watching new to this video, so yesterday I have covered chapter 1, which is real numbers. So all three case studies which are mentioned in the main website of CBSE regarding the question bank. So in that we have covered three case studies, so total 15 questions are done in yesterday's video, and in today's video we are going to cover the case study questions of chapter 2. Okay, so chapter 2, you can see there are total 3 case studies, and each case study they are having 5 questions each. So we're going to cover all 15 questions today, and also cover if any important point is there with respect to this topic. Okay, so let's start with this video. So let's see the first case study. The first case study they are saying is the below picture are few natural examples of parabolic shape which is represented by a quadratic polynomial. A parabolic arch is an arch in the shape of a parabola. In structures, the curve represents an efficient method of load and so can be found in bridges and in architectures in variety of forms. You can see there is one bridge here which is a parabolic shape. So parabolic shape is nothing but a U kind of shape which is having a common horizontal point and again forming another U shape. So it can be upward or downward. Here is the examples of upward parabolas. Okay, so this is also like this, so which is pointing downward like this. Okay, if any parabola is like this, and it is called upward pointing parabola, and this way you can solve it as downward pointing parabola. Okay, let's see the questions now. In the standard form of a quadratic polynomial, a, b, c are. Okay, so a, b, c, let's see the conditions, are all real numbers, or all are rational numbers. A is non-zero real number, and B and C can have any real numbers. All are integers. The answer should be C. A should be non-zero. Why A should be non-zero? Because if A is 0, then what will become? This whole term will become 0. Then only B plus C will be, Bx plus C will be present, which becomes linear equation. But they are asking in terms of quadratic. Quadratic means the highest power should be 2. Or I can say simply degree should be equal to 2. For degree equal to 2, then the x square coefficient should be present and it should not be equal to 0. Okay, hence A is a non-zero real number and B and C can be having any real numbers, it can be 0 as well. Okay, but A should not be 0, because A is 0, the next term will also become 0. Okay, let's see the second question. So before that, I'll get a small topic. If I have something like Bx plus C, I call this equation as linear and the degree is equal to 1. If I have the quadratic standard equation, which is ax square plus bx plus c, then this is quadratic and the degree is 2. If I have only c, then it is constant and the degree of constant is 0. Okay, for degree to be 3, we call it as cubic. For degree to be 4, we call it as fourth power, and with the row specific name for it. Okay, so same way it goes on with respect to the degree value. Let's see the second question. If the roots of quadratic polynomial are equal, then the discriminant. So for this we have total 3 conditions. So discriminant, if it is less than 0, we call it as no real roots. If discriminant equal to 0, we say that 2 real roots, and those 2 real roots are equal. And if D, that is discriminant, greater than 0, then we call it as 2 real roots and distinct. Distinct in the sense both are not same. And repeating this topic, this is important. It can occur for 1 to 2 marks. based on discriminant. If discriminant less than 0, no real roots, equal to 0, 2 equal roots, 2 real roots and both are equal. Discriminant greater than 0, we have 2 real roots and those are distinct, that is different. So in this question they are asking about equal. Equal, what is the condition? D should be equal to 0, which is D. Okay. So next move to the next one. If alpha and 1 by alpha are the zeros of a quadratic polynomial, then k is equal to. So whenever you have like this, one is reciprocal of other, then simply use product of zeros. So product of zeros formula is C by A. So product of zeros, here it is alpha into 1 by alpha, which is C by A. So here the C is constant, which is 8k, by A is x square coefficient, which is 2. So alpha into 1 by alpha is 1. 1 is equal to 8 by 2 is 4. 4k. So the k value is 4. If moved to the left side, becomes 1 by 4. B is the right answer. Let's move to the fourth one. The graph x square plus 1 is equal to 0 intersects x-axis at two distinct points and touches x-axis at one point, neither touches nor intersects x-axis, either touches or intersects x-axis. Okay. Yeah, hi Vinayak, thanks for joining. So Vinayak, in this video I'm discussing about question bank series, and yesterday's video I have covered like regarding real numbers chapter, and in today's video I'm going to cover polynomials question bank series. So that is total 15 questions I'm going to cover today. So 3 questions are done. Currently we are in 4th question. So let's continue. The graph x square plus 1. So here if you write what are ABC values, A value is 1, B value is nothing, 0, C value is 1. So what is D value now? D is nothing but B square minus 4AC, so which is 0 square minus 4 into 1 into 1. So I'm getting the value as minus 4. So this value, D value is less than 0. If D is less than 0, we don't have any real roots. So simply it neither touches nor intersects x-axis. Okay, so for x is, if the roots are 0, then it touches x-axis. If D is greater than 0, it touches x-axis as 2 points. But here we are getting D value is less than 0, so it is neither touches nor intersects x-axis. Okay, let's see the 5th one. If the sum of roots is minus p, product of roots is minus 1 by p, then the quadratic polynomial. So this is important. If they have provided you sum of roots and product of roots, the standard quadratic polynomial is x square minus of sum of roots into x plus product of roots. Okay, so here I can simply write x square minus sum of roots is minus p, so minus p into x plus product of roots, they are saying here minus 1 by p, so this becomes x square plus px minus 1 by p. So this you can simply multiply into k as well, because this will anyway equal to 0. So x square plus px minus 1 by p. C is the right answer. Okay, let's move to the second case study and let's solve those questions. So the second case study is saying an asana is a body posture originally and still a general term for sitting meditation pose, and later extended in hatha yoga and modern yoga as exercise to any type of pose or position, adding reclining, standing and inverted twisting or balancing poses. In the figure, one can observe that poses can be related to representation of a quadratic polynomial. Okay, you can see this is a parabola kind of structure. Here is again another parabola and this is another. So these are nothing but representations of any quadratic formulas. So let's see the first one. The say for the poses, it is easy, which is parabola, because it is something like this or like this. Okay, the graph of parabola opens downwards. The graph always opens downwards when a value is less than 0. Okay, so just remember, if it is something like this, then definitely the x square coefficient is less than 0. If the graph is like this, upward, if it is facing upward, then the graph a will be greater than 0. Okay, if a is 0, then I told you it is a linear. So a is greater than, it will upward, a less than 0, it will downward parabola. So they are asking parabola opens downwards, then simple a value is less than 0. Let's see the third one. In the graph, how many zeros are there? So zeros are nothing but how many times it is touching, the graph it is touching or intersecting x-axis. So here you can see it is touching at this point and this point. So total number of zeros are 2. And what are those zeros? Minus 2 and the zeros are minus 2 and 1, 2, 3, 4. Minus 2 and 4 are the zeros. So let's see fourth question. So simply they are asking zeros which are minus 2 and comma 4. So simple, wherever it touching x-axis. Wherever graph is intersecting x-axis. Okay, let's see the fifth one. The zeros of a quadratic polynomial. Okay, so the provided polynomial and they are asking the zeros of it. So simply fine. So for this you can write what is the sum of zeros. Sum is minus b by a, so it is minus 5 by 4 root 3. What about product? Product of zeros is c by a. I'll write the formula as well. Minus b by a, and product of roots is c by a, which is minus 2 root 3 by 4 root 3. So root 3 root 3 cancels, 2 1s to 2. So product of zeros should be minus 1 by 2. Let's see which product of zeros is minus 1 by 2. Here it is not possible. Here root 3 by 4 by minus 2 by root 3. So 3 goes to the top. Becomes minus 3 by 8. So this is not possible. I'm sorry, it should be product of roots, not sum of roots. So if I do product of roots, minus 2 by root 3 into root 3 by 4, so this begets minus 1 by 2, so this can be changed. What about here? 2 by root 3 into minus root 3 by 4, this is minus 1 by 2, so this also there is a chance. Here this is not possible, because if a product minus into minus, will get plus. So in these two I have to check whose sum is this value. Okay, I'll simply check one, and if it is not possible, then the other will be the right answer. So here if I add these two, minus 2 root 3 plus root 3 by 4. I'll get the LCM as 4 root 3, and this becomes minus 8 plus 3, which is minus 5 by 4 root 3. Hence it is satisfying. So the answer is B. Okay. So sum of zeros and product of zeros are mentioned. To simply check sum of zeros and product of zeros, and either one of the answer will be correct. So I'll write it again neatly. Product of zeros for B and C options. So product is minus 2 by root 3 into root 3 by 4. Root 3 roots get cancelled out. This becomes minus 1 by 2. For this way, same as for C option also, it will be minus 1 by 2, because 2 into root 3 into minus root 3 by 4. The root 3 roots gets cancelled, and this also gets minus 1 by 2. But the sum of zeros for this value, it is minus 5 by 4 root 3, whereas here you will get plus 5 by 4 root 3. Okay, hence the only answer is B. Let's see the last case study for today. Basketball and soccer are played in with a spherical ball. Even though an athlete dribbles the ball in both sports, a basketball player uses his hands and soccer player uses his feet. Usually the soccer is played outdoors on a large field, and basketball is played indoor on a court made up of wood. The path traced of a soccer ball and the basketball are in the form of parabolic representing quadratic polynomial. So you can see here, whenever in a basketball game the ball wants to go into the ring, it has to travel a parabolic path. Same way in a football or the soccer match also, whenever the football or the player hits the ball, it also travels in a parabolic path to goes into the net. Okay, so this parabolic path we are talking about because all the quadratic equations are represented in the form of quadratic formula. Okay, let's see the first one. The shape of the path traced we already studied, which is parabola, because it is going in this way. Okay, second one. The graph of parabola opens upwards when a is greater than 0. I told you again, if parabola upwards, then a is greater than 0. If parabola it is facing downwards, then a should be less than 0. And this is the case when it is equal to 0. If it is equal to 0, it will not be parabola, it will be just a straight line. And we call it as linear equation. Okay. Let's see the third one. Observe the following graph and answer. Okay, we need to answer in the next slide. In the above graph, how many zeros are there? So if you notice how many times the graph is intersecting x-axis, those are the number of zeros. Here there is 1, 2 and 3. So total 3 zeros are present. Graph is intersecting 3 times. The zeros in the above graph, so simply zeros are asking, it is minus 3, minus 1 and minus 3, minus 1 and 2. I'll just zoom this so that it will be easy to understand. Hope now it is clear. It is minus 3, minus 1 and 2. Minus 3, minus 1 and 2. So D is the right answer. Okay, next is the last question. What will be the expression of the polynomial? Okay, so this can be solved in 2 ways. I will solve both the ways. So first I will solve using expression. So what are the zeros we got? Minus 3, minus 1, 2. Minus 3, minus 1 and 2. So simple. It becomes x plus 3 into x plus 1 into x minus 2 I have to do. So this becomes x square plus 3x plus x plus 3 into x minus 2. So this becomes x square plus 4x plus 3 into x minus 2. So this becomes x cube minus 2x square plus 4x square minus 8x plus 3x minus 6. So this becomes final answer x cube plus 2x square minus 5x minus 6. Answer is here. So simply whichever zeros are there, you have to write in form of x minus a into x minus b into x minus c to get the answer. Okay, I told you we have another option as well, so that is using sum of roots, product of roots, and product of two zeros. Okay, so sum of zeros is, for a cubic equation, it is minus b by e. Product of all is c by a, and the combination of product like ab plus, okay, write the values as alpha beta plus beta gamma plus gamma alpha is d by a. So this is minus c. Wait. So this is c by a, and the last is minus d. Okay, so sum should be minus b by. What is the sum of all this? Minus 2 minus 4 plus 2 is minus 2. Sum should be minus 2. So we can notice all are minus 2 because minus b by a. Okay, so last one. Okay, second we'll see alpha beta plus beta gamma plus gamma alpha. I told you it should be c by a. So if I do minus 3 into minus 1 is 3, minus 1 into minus 2 is minus 2, plus 3 into minus 2 is minus 6. So this becomes 3 minus 8, which is minus 5. So which is having minus 5 is option, so these two are eliminated. The last one is d by minus d by e, so it should be product of roots is 6 plus 6, so minus 6 minus of minus 6, which is plus 6. So that option is here. So in your exam you can follow this method or this method, but I suggest to follow this method because this, if you do properly, you can 100% tick the right answer. Here, if any small change like minus b by a instead of minus b, if you wrote plus b by a, minus c by instead of you wrote minus c by a, then your answer will go wrong. So whenever you have zeros and if you ask a equation, simply substitute in this way: x minus a into x minus b into x minus c. Alphabet a, b, c are the roots here, and then get the equation. Then finally you'll get the right answer. Okay, so in this way all the case study questions related to quadratic equations, polynomials are been done. In the next video, that is mostly tomorrow, we will going to cover linear equations in two variables, 15 questions. So thanks for watching. Next video, linear equations in two variables. So first 5 chapters I can say are almost direct straight questions, and the next remaining 7 chapters there can be little lengthy. So based on it, I'll try to solve at least 1 or 2 case studies if it is lengthy, or else I'll try to cover all 3 case studies chapters. Okay, so in this, from the second chapter, the weightage is a bit less. It can be around 2 to 4 marks, but the concepts are simple. I'll just repeat the concepts related to the second chapter. So here I'll repeat. The second chapter main concepts are, we have to understand based upon degree. Degree is 0, linear. If degree is 1, degree is 0 is constant. Degree is 1 is linear. Degree is 2 is quadratic. And degree is 3 is cubic polynomial. Then we have for quadratic equation, sum of zeros is minus b by a. Product of zeros is c by a. So based on it we have to find it, sum of zeros, product of zeros, and simply whatever might be the condition, based on it you have to do it. Okay, and then we have parabolas. Upward parabola, a value less than 0, a value greater than 0. Downward parabola, a value less than 0, and a equal to 0. I told you it's a linear, it is not a parabola. Okay, and then last we have point intersecting x-axis, so zeros are the ones intersecting x-axis. So if you just remember these concepts from this chapter, then you can be able to solve any questions related to this. Okay, so in this way we have covered total 15 questions for today, and those are related to the second chapter, which is polynomials. So as I mentioned, tomorrow we'll try to start another video where we'll have covered the case study questions related to linear equations in two variables. Okay, we'll cover all 15 questions tomorrow, and mostly around the same 2 p.m. time I'll try to start this video. So thanks for watching. Let's meet again tomorrow at 2 p.m. with linear equations in two variables, all 15 questions.